So this is how to solve a system of equations with substitution. Okay. So back to what is a system of equations. It's two or more equations. This is from yesterday, or which is today, but anyways. So this is a system. This is just a symbol to show it's a set. Remember that there's three different types of solutions. There's one solution where they're crossing. There's no solution where they're parallel lines. They never touch, and therefore that's why there's not a solution for both of them for that system. And then there's infinite solutions. And remember, this is two lines on top of each other. So when they're on top of each other, that's touching every single solution. That's why it's infinite solutions. This is a different method. It's called the substitution method. These are the steps. I'm going to skip to the next slide so you can actually see me put the steps into play. Okay, so here's our system, our two equations. First, we're going to rewrite one of the equations so that it's y is equal to or x is equal to, okay? Well, luckily for us, we already had one. We already had one that was y is equal to something. So now we are going to substitute the expression, okay? This is the expression that is equivalent to y. We're going to substitute it into the other equation. Where? Where are we going to put it? Well, if y is equal to this, then we're going to put this in for y right there. Okay, so what do I mean by that? Rewrite everything except for when you get to y, we're going to do something different. 3x plus 8. So now instead of writing y, I'm going to write this whole thing. And I'm going to put it in parentheses. Why? Because 8 was times whatever y was. So now it's 8 times this whole thing is equal to -5. Just at this point, I want you to stop for a second. The only thing that's different about this and this is that instead of writing a y, I'm writing this whole thing. Why am I doing this? I'm doing this because you can only solve for one variable at a time. And if there's two variables in here, I can't figure out what x is or what y is. But now I have only x's. So let's go ahead and do the distribution. 3x plus 8x, and then that's going to be 72 is equal to -5. I can simplify 8, 9, 10, 11, 11 x's plus 72 is equal to -5 minus the 72 minus the 72. What are we doing here? We're solving for x. That cancels out. 11x is equal to -77. Dividing by 11 on both sides because that's going to get me -7. Okay. So we solve for one variable. That's what we just did. Now remember, a solution is an ordered pair. So I just found the x value of my ordered pair. Now what can I do with that? I need a y as well. I'm going to substitute the value of the known variable, -7 for x, into the equation and solve for the unknown. This is where people get confused. They're like, well, where do I put it? Do I put it here? Do I put it there? Do I hit the wherever you want? So I put it in the place where I think I have to do the least amount of work. So I'm going to take this -7 and I'm going to substitute it into this equation for x. So maybe I'll even change my color so that you see this is like a different step. So I'm going to say y is equal to, maybe I'll just rewrite this first, just so you see what I'm talking about. I'm taking this equation right here. Now y is equal to -7 plus 9. So y is equal to 2. So that is my solution. Since there was a solution, there was one point that they shared, this is one solution to this system, and this is what the solution is. Okay, that's what we're doing. So let's go on to the next one. Oh, I think I have to click this first. Oh boy. Please just go to the next slide. Thank you. Okay, so now we don't have the convenience of the last question was that one of them was already written as just y is equal to. And so we could just start right away with the second step, substituting the expression. But we can't do that on this one. But we're going to rewrite this. Now, you could rewrite either one of them for x or for y, but the easiest thing to do is just subtract 2x from this side, subtract 2x from that side. Y is equal to a negative 2x plus 9. Okay, now I've rewritten this equation into this. So I can now take this expression. I'm going to take this expression right here, and I'm going to substitute it not into the same equation. That is like a puppy chasing its tail. You're never going to go anywhere. But into the other equation. So where the y is in this equation, that's where I'm going to put this. So I'm just going to rewrite this. 2x minus 3, but instead of writing y, I'm going to write this whole thing. And I always use parentheses, which mean to multiply. So everything here is the same as everything here. Only thing different is instead of writing y, I wrote this whole thing. Okay. 2x plus 6x, just distributing here, minus 27 is equal to negative 11. And that's going to give you 8x minus 27 is equal to negative 11. Just solving my two-step equation here. 8x. If this is going too fast for you, you know you can re-watch. What is going on here? What's the problem? There is no problem. Everything is fine. This is 16. Okay, divide by 8. Divide by 8. X is equal to 2. Okay, so you know what you're trying to find. Trying to find an ordered pair. And you just found the x value, which is 2. Now, what do you do with the 2? You're going to substitute it back in. You can put that 2, remember that 2 can go anywhere in for x, okay? So I guess I'll substitute it into this equation. It could be any one. This one just has less numbers, so I might do it. Truthfully, this would actually be the easiest place to substitute it in, but we'll do this. We'll do this. Okay, let me change colors, and I go 2, but instead of x, I'm going to put 2 plus y, just follow along here, is equal to 9. That's where I got this information. I found my answer for x. I substitute in for x. 4 plus y is equal to 9. So y is equal to 5. And so that is our ordered pair. And this system has one solution. Has one solution, and that's what the solution is. Okay, remember, you can always pause if this seems like it's going too fast. You fast forward if you think it's going too slow. Okay, I wanted to show you this example because in this situation, it's better to solve for x than to solve for y like we have been doing. So in for x, I'm going to rewrite it over here. So x plus 5y is equal to 4. And I want x all by itself. So minus 5y minus 5y. X is equal to minus 5y plus 4. Now I'm going to take this whole thing. I'm going to take that whole thing and I'm going to substitute it. Don't substitute it into the same equation that you just got it from. Again, that's just going to run you in a circle. So you're going to take this and let's put it all the way up, right in there, right in there. Okay. So we've got 3 But instead of writing x, I'm going to write this whole thing, because this is what x equals. Substitution. That's what this method is called. Now just continue to write the rest of the equation. Okay, so now I only have one unknown, one variable, and it's a y. So I'm going to solve for y now. 3 times, that's negative 15y, plus 12 plus 15y is equal to negative 1. Okay, well, when I combine this and this, that gets me no more y's. So now I have 12 is equal to negative 1. What? Baffling. What has happened here? Okay, well, maybe you remember from when we solved multi-step equations, you could get a solution, you could get no solution or infinite solutions. First of all, is this a true statement? No, so put a line through it. Okay, and what this means when the variables have canceled out and you end up with a false statement, that means there is no solution. How would we verify that we did it correct? Type these into Desmos just as they are, and you're going to see parallel lines. Let's see. I'm not sure which way the slope would go, and I don't want to waste your time figuring it out right now, but they would be lines that never cross, right? Because they have the same slope. I think, yeah, actually they would have a negative slope, and I drew positive. Sorry. Anyways. So we're done with that problem. It has no solution. That's why we can't come up with an ordered pair that they share. They don't have one. And okay. So I guess I was going to have you type these into Desmos. And, okay. We're not going to do that. Let's see. Is there anything else that I need to show you? Okay, this type, you can type into Desmos by yourself. Like, you can figure that out, I think. But I want to show you the math part. If this is equal to y, if this is equal to y, and this is equal to y, then they are equal to each other. Think about this for a second. If I said 3 plus 4 is equal to 1 plus 6. And then I said that 5 plus 2 is equal to 1 plus 6. Then wouldn't you have to say, if this is equal to 1 plus 6, and this is equal to 1 plus 6, then isn't this equal to this? Isn't 3 plus 4 equal to 5 plus 2? Yes, that is true. That is a true statement. And that's one of our properties. Okay, so we are going to set these equal to each other, as I tried to show you here, because if they're each equal to y, then they are equal to each other. So 4x minus 1 is equal to 2x minus 5. Now, Miss Wimbush says, well, they're both in y equals, just go graph them. Yeah, I know, but we could still show you how to do substitution when they're both y equals. So minus 2x minus 2x. But she is right. 2x minus 1. If they're both in y equals, why not just graph them? Plus 1, 2x is equal to negative 4. Divide by 2, divide by 2. It's equal to negative 4. So I found this. Now I've got to utilize one of these two equations to figure out what the y value is. So I know that my solution is at least negative 4. But what is the y value? Okay, I'm going to pick the one with smaller numbers. Y is equal to 2 parentheses negative 4 minus 5. Y is equal to negative 8 minus 5. Negative 8, 9, 10, 11, 12, 13. 13, negative 13. So negative 13 is our ordered pair. And so this has one solution. Okay. You can always pause it. Otherwise, I'm going to throw this in the trash. Okay, I think that's we've covered everything here. So you look at these you look at these and what kind of solutions would you get? So if you solved this, then you would get an ordered pair. You would get an x value and a y value as answers. If you are solving this, you're going to end up with two numbers that are not equal to each other, and the variables cancel out. And so you just are left with these two numbers that are not equal to each other. And that shows you no solution. And you should remember that from when we were solving equations, this would also occur. And the answer was that there was no solution. And then you have when the variables cancel out and it's the same number and it is equal to each other. And that is infinite solutions. So this is one solution. This is no solution. And this is infinite solution. Solutions. If this is what it looks like on a graph, this is what this one looks like on a graph. This is what this, remember, this is two lines, right? It's two lines on top of each other. This is what it looks like when you use substitution, and these are the solutions you get. You either get values for x and y, you get no more variables, the variables cancel out, and you get two numbers that are not equal to each other, or you get two numbers that are equal to each other. Okay, I think that's it. We've covered it.